So let me introduce myself. My name is Alif. I work with Sunset Learning Institute. I'm outsourced to Cisco.com. I work for Cisco Solution Readiness Engineers, or we call it SRE. And our team mission is to enable the Cisco partners and customers to use new products and technologies. And to do that, we host and develop lab contents and conduct boot camps, tech talks, and hands-on lab. Today, I'm going to introduce you to Cisco DNA Center, and want to let you know that this is the first of two series. Today, we're going to discuss Cisco DNA Center, and tomorrow, we're going to talk about Cisco SDA Fabric, or Software Defined Access. So let's take it away. So everyone heard about intent-based solutions or intent-based networking. The best way to understand what is intent-based networking is to go for an example. Intent-based networking has major three pillars. It's the translation, activation, and assurance. Translation is by defining the business requirements. Activation is by translating these business requirements into policies and apply these policies to your network through a controller. And in our example, DNA Center will do that. And assurance, which is checking that your configuration is doing what it should do and it meets your business requirements. And DNA Center does the same in our case here. So let's go an example of QoS deployment. QoS deployment will give me the best example for the difference between traditional networking and intent-based. So for QoS configuration, we know that we have different platforms and the configuration change based on that platform and based on the version of the operating system. So if we need to configure QoS, we need to go to each device on the network and we need to customize the configuration and apply it to the interface, and we need to define which orientation we need to apply these configuration to. This is a cumbersome and this is consume a lot of time, and I know that a lot of engineers don't like to do that, but there were no better way to do that. The only way was to go to every device, customize the configuration, read the reference guide, read the OS version, and use that device to the best of your knowledge about the capabilities of that device. DNA controller can automate the QoS configuration end-to-end, and it translates the business intent into a policy, or what we call it, a strategic or tactical policy, and that policy will be applied across the network. So DNA knows what is each device role in your network, where it's connected, who are the neighbors, and what are the software capabilities which is supported on each platform. So this automation process helped making the configuration consistent, so eliminate human error, and it reduced the cost. It has major reduction on cost and time. The best example for traditional networking, I can bring the Prime infrastructure here. This is a screenshot of Prime infrastructure. Most of you has used it in the past, and maybe it's still operational in many networks. Prime infrastructure can do QoS configuration, but what it does really, it just translates the CLI options into GUI, which means I still need to know what device, what software capabilities before I deploy the QoS. And I have to go box by box or group of devices to define where and what to apply and where and what need to be configured. This is the main difference between intent-based networking and Prime. Let's go to DNA Center. Let's see how DNA Center will handle this process. This is a screenshot from the DNAC. Take a look here. Let me grab here. Then you can see on this side here, we have three categories of applications. We have business relevant, default, and business irrelevant. These applications are classified by Cisco based on a huge amount of telemetry data collected from live environment. And it defined these applications as relevant to your business, not relevant to your business, or default, like it's used like by any user. For example, an internet internet, we do not consider it business relevant. We consider it as default, so we don't need to assign higher priority or we need to give it more bandwidth than other applications. So based on these three categories, once we define these applications, and by the way, we can customize these applications. We're going to see in a demo how we can do that. We define the site scope. So we define where we need to apply this policy. Is it going to be applied to branch 1, branch 2, or the whole network, or only to the headquarters? Once DNA get these configurations, it will deploy QoS, and these applications which are relevant to my application going to be prioritized on all types of WAN carriers, no matter what platform is connected to that WAN carrier. DNAC will deploy QoS automatically and will interact with the admin to confirm that it's going to deploy the right configurations. So some people get scared. Is that going to do all the work on its own? No. It's going to send you a pop-up message with CLI configuration, so you can read it and confirm if you like to, or maybe you make changes if you like to. So the big question is, what is DNA Center, or what is DNAC? DNAC is essentially a controller and analytic engine. Both are built on a single platform, and it is hardware-based appliance, so it's not going to be in virtualized. There are some virtual appliances released in the past, but because this application or this appliance is a monster that require a lot of resources, it was not performing good, so it's not going to be used in lab, and Cisco decided that it's hardware-based only, and it can be deployed in one node or a cluster of 3 nodes for redundancy. These are some of the use cases supported on DNA Center, and all of these capabilities can be implemented using GUI, or we can do it through REST APIs if you're a DevNet guy or you prefer to do automation by scripts. We'll demo many of these capabilities today, but let's take a look about what we can do with it. The first 2 columns will be the subject of today's Tech Talk. We're going to see how we can do client onboarding. We're going to go to configure a wireless controller and wireless network on a site. We're going to do day 0 automation or plug and play. And also, if we have time, we're going to look for application policy. Tomorrow, we have another session at the same time. We're going to talk about SD access, and it's very important for everyone to know the difference between DNA and SD access because it's a little bit confused sometimes. DNA is just a controller. You don't create any fabric. You don't make any change to your network. It's just a controller to help you to do your work. Once you say, I'm going to move to SD access, that means you have certain requirements, which we're going to discuss tomorrow. And you create a fabric, and there are certain rules you need to apply, and then you migrate your devices to software-defined access fabric. So some of the use cases which we are going to review today will be around onboarding a new device. This is use case 1. We're going to see some screenshot and discuss how we can do that. The next one will be SWIM, how we're going to manage our software and do upgrade in automated way. Third, we're going to do a quick wireless deployment. We will have our wireless network already configured. We're just going to extend it and apply SSID to one of the branches. And the last use case is review the application policy through an example of end-to-end QoS deployment. We are going to use a shared environment today on dCloud. So this will be a little bit sluggish, not going to be performing in the way we like because it's shared and there are a lot of people using it. Before we use Cisco DNA, once we bring it up, we need to introduce it to our network. So there are certain configuration you need to do to make it ready to help you in your work. First, you need to define the network hierarchy by defining sites, buildings, floors, and then maybe uploading floor plans. In this example, global means all our networks. We have United States of America, and we have another area called San Jose. Then we have a building called branch, and we have a floor here, floor 1, and these will allow us to make changes or add maps to these floors. Now, what if I have network hierarchy configured in Cisco Prime? Can I export it? The answer is yes. Versions prior to 2.0, there were some limitation, like maximum number of sites was 500. Now I think you can import more, but if you have like 2,000 sites in Prime infrastructure and you're going to import it to DNA, it may not be a very easy way, but Cisco is reducing this difference between Prime infrastructure and DNA in the new releases, and soon you're going to be able to omit this difference. Next, we need to define essential services on the network like DHCP, DNS, syslog, AAA, servers. We need to define these IP addresses here and the domain name, and we apply these configuration to the hierarchy. So if we apply these configuration to global, that means all children, locations, and devices can inherit these configurations. So any device I add to campus, it will have the DHCP 1.1.1.1 configured automatically and the domain name cisco.com. What if I want branch to have different configuration than campus? Then I can click on branch here and maybe change the primary DNS to 2.2.2.2. That will override the global. So every device in USA, San Jose, or campus will have the global configuration except branch. These configuration will be overridden by my configurations. The third step is, as you've done in any other network management system or Cisco Prime, we're going to discover the network. So similar to what's done in Prime, we're going to use SNMP, SSH, Telnet, CDP, LLDP, or adding IP range for discovery. And don't forget that you need to provide credentials for SSH, Telnet, or SNMP, both V2 and V3. Once devices are discovered, it's going to be shown here on the screen, and it will tell me how this device was communicated with. So this device 10.1.8.2 is up and reachable, and was reachable through ICMP, so it's pingable, and we could access this device through SNMP and CLI. So I can read all configuration, and now that device will be added to the inventory. Once I discover the devices, I need to go to the inventory and check the status. This is my inventory in DNA. I have a list of devices and IP addresses. It will give me the status. Any device goes unreachable. It's going to show me X here. I have the information which I get from show version. Uptime is since 17 hours. Last update, this is the last time it was reachable by DNA. So 3 minutes ago, DNA was able to reach 5520, and it was able to synchronize the configuration over 25 seconds. Now, the most important part is the last sync status, managed. Once you see it's managed, that means DNA was able to access. It's not just reachable by ping, it's accessible by CLI and SNMP, and it's able to read the configuration and start do the management on your behalf. The site, we're going to see that this will be the next step. Some devices are unassigned here. This is a fresh discovery. I can assign these devices to sites based on my hierarchy. This is step number 5, select devices and assigning them to sites. So in our demo today, we're going to create a site. We're going to rerun discovery. Once we find a device, we're going to assign it to the new site. Now, this is optional. Once all devices are discovered, assigned to site, you can review the topology. This topology is going to be created by DNA automatically based on the discovery. It will show you the connections. And if you can see here that we are on a global site, so we're going to see all network devices in our DNA. If your network is big, you may need to zoom in and out, or maybe you cannot see all of the parts. You can play around with the mouse. But if you click on campus in San Jose, in this case, you can see devices and network only in that branch. Once we've configured our DNA center to be able to do the discovery and prepare the sites, I can start use it to onboard new devices by plug and play, or maybe deploy new wireless networks, or maybe update the software image. Let's go for the first use case, and you're going to see that in the demo also after we've done with the screenshots. So we can deploy multiple new devices as part of day zero operation using the DNA zero touch. So plug and play is equal to zero touch provisioning. And if you are working with SD-WAN, in SD-WAN, it's called zero touch provisioning, or ZTP. Here is called plug and play. So most of the users or big companies ship new devices to pre-staging facility, and they configure them. Then they ship them to the site, and that's really costly and time-consuming. With DNA plug and play, we can start planning the requirements before these devices are shipped to the site. So while I'm ordering it, I can have the serial number of these devices. I synchronize DNA to my smart account. And once I have these serial numbers, I can start the process of provisioning these devices by creating templates and decide what image version I want on this device, what initial configuration I want, and we call that day zero template or onboarding template, and what REST configuration I need. And these templates, we're going to see that it allow to use variables. So if you're going to deploy, let me say 20 devices, you don't have to create 20 templates. You create one template and you make the host name and the interface IP addresses as variables. Once you assign these templates to the device, you define these variables. So one template will serve for the configuration of 20 devices or 100 devices. So this is how a plug and play screen will look like. You can see the serial number here and the switch product ID, which site is assigned to, what image is going to be installed, and what template we selected to be applied. Now, again, I want to stress on this point that initially we use day zero template because the configuration which we need initially could be different than the configuration which we need for the operation. We don't want the device to join immediately as part of the network because it may go in like sort of transit, instability, and it may affect the overall routing performance. So what we do is we create a day zero template, which allows the switch to get the major configurations like hostname, IP address, management, all of these stuff. Once we know that this device is functional, up and running, and managed by DNA, then maybe we can apply the day two template, which is routing and switching, and let it join the network. And we will be sure at that time that it's going to do the work without any transit outage. So we just define the configuration and wait the device to make contact. So we did not send the device to the site. We just order it, and Cisco is shipping it, and we've done all the work. Now the device is reached to the site. Let's say it's reached to campus environment. Now we need to configure DHCP and DNS server in that campus. So the DHCP has option 43, or we can use option 60. That option will point the device to DNAG on port 80. So at this point, the device knows once it's boot up and get the DHCP IP address, it will know where the DNA is, and it will establish communication on port 80. Now, DNAG will receive the first communication from that device. First, it will compare the serial number of that device to the one deployed on it. If it match, then it's going to send a certificate to that device, and that certificate will establish a trust communication between the DNAG and the new onboarded device. If the serial number is not there, it's going to block the configuration and not allow the device to join the network. Now, the device is whitelisted, and a certificate is sent, and trust relationship is started. There's a long process. We can talk about it in a separate tech talk. now the device can switch from port 80 to port 443. With a new secure channel now, DNAC can push the image. Let's say I define golden image for these type of devices, then it's going to apply the rest of the configurations. Now the device is provisioned and added to the inventory, and it can be part of your configuration. Just imagine this process for 1,000 or 2,000 devices. You make the order, you don't touch any of them. You just send them to the sites and let someone plug internet or plug local LAN, and the process is automated. There are a bunch of different options for the device to find DNAC, and there is a process. First, if we have DSCP options 60 and 43, the device will get the IP address for DNAC, and it will establish the communication on port 80. If DHCP is option 60 or 43 is not configured, or for some reason it didn't work, it was configured wrong and pointing to wrong server, I can have a DNS record in my network, PNP server.localadmin, which is pointing to the DNA server. So if DHCP option 60 or 43 failed, the device will try to resolve PNP server.localadmin. Your DNS server will give it the IP address, and then it will connect to the DNA server. The third option, if both fails, is going to do cloud redirection. So it's going to try to reach devicehelper.cisco.com and use your smart account and use your organization name and Cisco records to try to reach your DNAC. And we're going to talk about it in later slide. There are certain sites which require like configuration of one IP address. You cannot put DHCP. For example, your ISP doesn't support DHCP. In this case, you can provision a bootstrapping USB flash and send it to the site. You can just plug it in and bootstrap that device. The device will get these IP address configuration and reach out to DNA. At this point, there is an argument if this is a zero touch or not. I don't know. You can decide if it's zero touch or not, but I consider it still part of plug and play. Manual, it's available there. We can just use Cisco installer app on your iPhone or iPad, connect it to the device and let it get the configuration, and then it will reach out to the DNA center. Now, in case of cloud redirect, how it works. We know that when we order a device on CCW, we can have the possibility to add the serial number immediately, and we can add it to our smart account. But it's not going to work automatically unless I made a selection. Once you select your product ID in CCW here, you need to select the network PNP license, and you're going to get this free license, which is network PNP license. If you get this free license, that means the serial number of this device is going to be added to your smart account and is going to be published to the device helper database of Cisco. If you don't do that, it won't happen. So make sure that you have it. So now this is how it's going to work. Device serial number will be synced to the customer smart account, and then it will be added to PNP Connect or the device helper database. Now, when DNAC is initially deployed, it will request your smart account credentials. Once you provide your smart account credentials and the controller is up, it's going to automatically register to the PNP Connect cloud, and it will do automatic sync, and you can do manual sync to collect the serial numbers and add it to DNAC. Now, PNP Connect Cloud has two things: serial number ordered in CCW and the DNAC IP address. So guess what? When a device will come over, it's going to try to reach DHCP, fail, then it's going to reach DNS, fail, then it will go to PNP Connect, and it will provide serial number. The PNP Connect has the serial number and know which organization it is, so it's going to respond with the IP address of DNA, and now DNA will establish the connection. A small note here about DNA configuration. When you go to settings, and we're going to see that in the demo, you go Cisco credentials where you added your smart account. You can click sync here. The sync is going to go to Cisco PMP and synchronize the serial numbers of your orders and bring it to DNAC so it can allow that device to communicate. So at this stage now, the device reached to PMP. It established SSL communication using certificate, as we talked before. Provide the serial number. Now PMP Connect allow that device to connect to the network. So it's going to give it DNA center IP address. It could be private IP address. It doesn't need to be a public IP address as long as this device, the new device, and the DNA center are on the same network. And now the device is going to reach DNA center, provide serial number. DNA is going to download certificate. A trust relationship is started. And now golden image will be pushed to the device, template will be pushed, and the device will come online. This is the overall process. This is just in case you don't have a DHCP or you don't have time or resources to deploy DHCP or DNS. The easiest way is to deploy DHCP and DNS on your network. If it doesn't work, Cisco PMP Connect is there for you. So here we need to remember that we need to create some configuration. As I said, it's we call it day zero template configuration. We need to assign that template to a profile, and that profile is assigned to the device, which is still not there. How we can do that? When we go to inventory, we can, or plug and play, as we're going to see, you will see some devices serial numbers, and there's no devices attached to it yet. You use that serial number to assign a template and a profile. And once the device is connected and it matches the serial number, it will take that template configuration automatically. The second use case you're going to see is SWIM, software image management, which is existing on other network management system. We all know that prime infrastructure can do that. But let's first compare the steps to update software image manually and by prime infrastructure before we go to DNA. So usually you plan the image, upgrade, you select your golden image, the best image you need for that brand, for that platform. Then you need to go manually to your inventory and look what devices has what image, and you decide which devices need that upgrade. Companies which have change management control, they need to create a change request. Someone will look at it and approve it. At that point, you can start your change. And here you're going to do pre-check validations. An example of pre-check validations, looking at the flash memory, if there are any space in that flash memory for the image. If there is no space, what to do? We need to clean up some space. It could be part of it like bug scrub, if you want to like forward it to your advanced services. It could be also compatibility of services. Once you pass the pre-check validation, you'll start distributing the image. You'll copy the image to these devices or that device. And after you've done the distribution, you need to check the integrity of that image. You need to check if it's altered or there was any errors during copying this device. Now you can activate the image, do the reboot, and you have the new image applied. Then you can do the post-upgrade validation, which is test script, and you close the CR. Cisco Prime can do only 2 steps, or any other network management system can do only 2 steps. The rest still need to be done manually. You need to plan, select, look what devices, do the change request, and the Cisco Prime will allow you just to distribute the image and activate it. Then you need to run the test, see if there's any error. Do you want to revert back or no? And then you close the change request automatically. Look at DNA, what's going to help you to do. You start the plan. Now, you have on DNA selected golden image, for example, for all C93 Catalyst 9300 switches. So now that device or DNA knows that all 9300 will have this golden image. Now, you're not going to look for what devices has this golden image. DNA has the inventory. It pulled all configuration, all information of these devices, so it know which device requires that upgrade. It will create the change request if you have integration with ServiceNow. And then once it's approved, Cisco DNA will run the pre-check validation for you. And the question is, what if there is no space on the flash memory of that router or that switch? Is it going to fail? We can make DNA go extra mile and clean up some spaces on that flash memory before start the distribution. To distribute the image, and part of that also integrity verification, as you can see, it's going to look for known good values, which we're going to download from Cisco. It will match the hash, SHA and MD5 hash, activate the image, run the test. If there's any error, it's going to send me event, no error. It's going to say life is good. And it will close the change request if everything goes good for you. So the whole process, end-to-end, is automated with Cisco DNA. Let's look at 3 screenshots how it looks like. This is my inventory here. And if you can see here, that golden image is selected for certain sites. So the DNA will check all devices in the inventory and report which device is outdated. So DNA sees that this device is outdated. Guess what's going to happen now? DNA is going to create a change request in ServiceNow to update this device. Once it's approved, everything will go automatically now. Now, DNA is capable of doing not just update, it can do patching. So if there is certain patching or SMUs available for this image, it doesn't need to upgrade the whole image and reload the router or the switch and cause outage. It can do hot patch, hot installation of these hot patches, and all automated without any outage. Now, if you provide your credentials to DNA when you deploy it initially, what that will help you to do? DNA will reach out to Cisco website using your credentials and will pick what are the suggested and latest versions of images for your device or for the inventory of devices you have. Now, if you define one of these images as a golden image, that means I want this to be installed everywhere, the Cisco DNA will go and download that image from Cisco website to DNA Center automatically without any intervention. Does that mean that all images will be available on my DNA? No. There are certain cases where the image repository will have offline copy of that image. First, if you define one image as golden image, like this example, any Cat3K will have this image as certain, which is 16.6.3. If you define this as golden image, it's going to download it and it's ready for distribution. The other way is manually. If you just go and say, I want this device to be upgraded to that version, if you select that version from the list, then DNA will download that version, or manually by selecting that version and say, I want that version to be on my device for future use. So one of them automatically, the other two options will be based on your consent. Now, someone will ask a question, don't we have the SWIM in prime infrastructure? Yes, we do. But what we can do here is just some options. We can select a device or group of devices here, and then pick the distribution and then activation. We need to select everything. We need to do the plan, select the image, do all the manual work. We talked about integrity verification. So another capability of DNAC is to run integrity verification here. So we can do that by what we call known good values, or KGV. It is files in JSON format. Cisco has these files for every platform, for every image. We can download it using our CCO account, and we can upload it to DNA. Now, once these images are distributed to the devices, the known good values files are used to confirm the integrity of this device. Also, the DNA will go another step and check the MD5 and SHA hash for you. So this is an example of Cisco known good values. It is a .tar file available at Cisco for different platforms. This is the SHA hash. Once you download the file, you have it all on DNA. Integrity verification will be done automatically for you. We talked also about software maintenance update, SMUs. Why do I need SMU? I need to reduce the downtime to the minimum, so I don't have to reboot routers. I don't need to upgrade everything. Maybe I need just to apply certain hot patch. Also, I don't need a big number of staff. I don't need to apply new code because new code require bug scrub, bug analysis, and requires certification. So big companies doesn't like to jump between codes so fast. I still can apply the SMU automatically using DNA. This is an example here. Once you get the SMU from Cisco, you upload it to DNA. Once you import it here, DNA will map it to the relevant image. You don't have to do that manually. Now you see here 16.6.2 is mapped to it, and say we have one add-on, and that now will be marked as golden SMU, and it will be applied automatically to the devices. We'll go real quick on wireless deployments, how we can do wireless deployments here. It's very simple in DNAC. We create SSID, we attach it to a profile, and then we associate the profile to a site, and then we define the WLC and the access points which we need on that profile, and we deploy it on that block. So no matter what type of configuration you have, Flex Centralized, you have Flex Connect, any type of connection is going to be done in the same way. You don't have to change the workflow. Now, the management of wireless controller is a big topic, and we can talk about it for hours, but DNA can do the wireless network management from zero to deploying your enterprise network, guest, and corporate wireless without touching the wireless controller. Once DNA discover that wireless controller, it will start communicating with it. Once you create this ID and profile, it's going to push the configuration, and it's going to bring the information about the access points, clients, customers, the health, sensors. All of these information will be brought to you through DNA. We will see a quick examples. I'm afraid that we don't have much time to run long demo, but I'll do my best. This is a very important part here. QoS. Look at this diagram. We have all devices, and all of them are different. Each device is different platform and has different image. The configuration of QoS is totally different between any two devices. I have to do that, or I had to do that in the past manually. I need to look to every device, every interface, and customize the configuration and do it my own. Now in DNAC, this is done easily using business intent. So when you express what applications are relevant to your business and what applications are not, that input is translated into QoS strategic policy, and the DNAC will configure the network to the best of what each of these platforms can support. So an example, if you have Cat9 device, we support multiple queues. And let's say you have video and audio applications, each will be assigned to one dedicated queue. But what if on the route we have all devices which support only one queue? In this case, both applications will be assigned to the same queue automatically. You don't have to do any of change. Okay, another question. What if one of the devices doesn't support NBAR, like Cat2K? How DNA is going to manage that? DNA will translate that strategic policy to ACL and will push it as layer 4 ACLs to these devices. So as we said, applications are categorized by Cisco to relevant, default, irrelevant, based on a lot of telemetry information collected from live environments. You can customize it. You can move any applications from any category to the other, and you can define new applications. What if Cisco doesn't have information about new application from Microsoft? Then you can define that application and add it to any of these categories. This is an example of how you can customize the configuration. We have 12 traffic classes classified as relevant, default, and irrelevant. So relevant applications here are classified as marked with different priorities and mapped to different queuing here. Let me see this one. See these priorities. Voice is critical, EF, and we have signaling is CS6. We need the network control to be higher priority than signaling, and admin or management OAM. Now, default, which may be internet traffic or maybe YouTube, we can apply it to the default queue. We don't have to give it any priority, and we can treat it as a best effort. And irrelevant, like scavenger, that will go when we have bandwidth, we can serve it. We don't have bandwidth, we don't care, we're going to throw it away. This is how the network, the screenshot of DNA will look like. These are the three categories of applications. And in this case here, I was moving one of the default applications to, which is, it was, I think, YouTube. I was moving it to one of the business relevant because I wanted to reduce the priority. You can see here that we can assign it to sites. So I want this policy to be only on single branch or 5 branches. Also, I can define here the queuing. For example, I want to give the voice 10%. I want to give video 20%. Rest will take 60. Scavenger will take 5. And here I can map the SP profiles. For example, if your service provider give you 4 DSCP or 4 QoS categories, you can map these 4 categories or 4 queues to whatever in your policy. Again, we can assign it here to sites. We can assign it to the whole USA, or we can assign it only to this branch. Do we have PI in QoS? Yes, but again, we create that template. We need to look to every device, every interface, and apply it inbound and outbound. This is a crazy, all of us done that in the past, and hopefully that will stop soon. Again, other NMS like Prime, it just translates CLI into GUI. So it's just changed from typing to mouse. That's not automation. DNA will provide the real automation in this case. Someone will ask me how DNA will treat IP phones or telepresence units. This is an example where the policy, the strategic policy, is going to be translated to ACL, and the ACL will be pushed to the phone and to the telepresence device, and maybe lower grade switches. We're going to see this SP profiles, and I'm going to go real quick. It's 1:45. I'm supposed to have questions, but I'll try to go real quick in a demo. I don't think I will have the time to demo everything, but let's go to this shared DNA. The username is demo. Password supposed to be secret here. And if you guys have access to dcloud, you can have access to this demo and do it yourself. dcloud.cisco.com. This is DNA Center. Look at the main dashboard here. It'll give me a quick review of my network. This is the summary, snapshot, how many devices, how many sites you have, how many policies applied, how many profiles you have configured. Do you have any critical events? And let me see critical events. I like that. Where is supposed to be? Critical issues, 0. Sorry, it's very healthy network. We have 65 sites. All of them are configured in this hierarchy. Let's first check what version of DNAC I have. I have 1.3.3.3, which is a little bit old. Now we're talking about 2.1, but for our demo, this is more than enough. You can check here what packages you have installed with your DNA Center, and you can get the serial number of this device, and you can ignore this VMware. Cisco will never make this available to anyone as a virtual appliance. It's just physical appliance. I can go here to the system settings, and the first page is going to drop me at System 360. Here I can get information about the cluster health, high availability if configured, and it will show me what are the external connected systems. This is a very important topic for tomorrow Tech Talk for the SDA. We have to have ICE in case we will have SDA Fabric. So this DNA Center is going to help us tomorrow to do SDA Fabric, and we're going to try to apply SDA in a box. But for now, I don't need to use SGTs or any other parameters from ICE, so I don't need to look at ICE for now. You can connect to IPAM, so you can bring all IP addresses. Even you will see when you work with DNAC that you need to define the DHCP subnets. These IP subnets are not going to be used as IPAM. DNA will not do IPAM work. It's just going to be for internal use or for system use. We will have here 4 or 5 main menus: design, policy, provision, assurance, and platforms. We're going to use design first to define the hierarchy. This is the first step, as we said. We have someone created these continents. We have North America, USA. Let me create a site for Sunset Learning Institute headquarters. I don't have Virginia here, so I need to create a new area, and I will call it Virginia. Now, I need to create a building in Virginia, and I will call that building Sunset Learning Institute headquarters. The address is 12120 Sunset Hill. Look at it. It's here, Reston. Once I select it, I have the coordinates, and I can put the coordinates instead of the address if I like. Now I have Sunset Learning Institute headquarters building created. Let me add floors. I have first floor, or floor number 1, and I can upload a layout. If you have any layout from AutoCAD, you can upload it here for your office. And once you upload it here, you can use this layout to allocate access points to do heat map, upload heat map from relevant applications, add sensors, and that will give a lot of information and telemetry to DNA. So I created my hierarchy. I have my device. I have my my building and my floor. Now I need to go and try to provision device. So next step here, I'm going to create network profile. Let's create a wireless profile. I'll go to design, network profiles. I have many here. I'll add a profile and let me do wireless. I want to extend wireless network to my branch. So what I will call the profile name, SLA headquarters. And let me add SSID here. What SSID I'm going to use? The corporate SSID, which I have already. It's enterprise, and it's part of Fabric. And which interface we are going to use? I'm going to use interface management because I'm not using SDA today, so I'm going to deselect Fabric. I saved it. Now, let me see where is my profile here. This is SLI headquarters. I need to assign site. So I will look for North America, USA, Virginia, SLI, and I'll say floor 1 and save. And that's it. I assigned that profile. Now that SSID will be broadcasted to that network once I add wireless controller and access points. So I did the provisioning before I send devices. Let's do some provisioning here. Let me go to provision from device inventory. You will see here that on floor 1 in Sunset, I don't have any device. But I can go to USA and see like I have all of these devices. Well, take time. Let me go to global. I want to pick WLC3, a wireless controller, and assign it to my device. So from here, when I select global, I get all devices which is connected to DNA. Let's click WLCs, and I see here campus WLC3. This device was in Chicago 5 on first floor. I want to change it to SLI headquarters. So I go to Actions, Provision, Assign Device to Site. And from here, I should have the option to remove it. I didn't have the option to remove it, so I'm going to check another one because maybe it is locked to the fabric. Let me check WLC4. Hopefully that I can do that. Provision, Assign to Site. Yep, choose site. It's not assigned to any site. So I'm going to assign it to my new office in floor 1. Save it, assign. So now this device is assigned to Virginia. If I go to Virginia here or floor 1, I can see that this device is here. Now I need to provision the device. And what provisioning means? Provisioning means whatever configuration I have for Virginia is going to be pushed to this wireless controller. And what configuration I have for Virginia now, or SLI? I have nothing, but they inherited all configuration from global. So let me go to design and see what global has, network settings and network. I select global. Now I have AAA server configured. This is ICE. I have also ICE as radius for client authentication. I have DSCP server, a DNS server, syslog server, SNMP, NTP, and time zone on top of message of the day. So these network settings are on global. So these will be inherited by any device in this group. So if I go to provision here and go to my device in Virginia, floor 1, I say action, provision device. This is the same site which I selected. Next. Next. Do I need to change any configuration? No. These are the configuration which will be pushed to the device. If I selected 20 device or 100 device, once I click deploy, these configuration will be pushed to that device. I don't think I will have the time to continue plug and play and check the applications, but probably I will have a chance tomorrow to go over this when we discuss the SDA. I want to ask if you guys have any questions. You can unmute yourself and ask any questions so far. If there's no questions, maybe I can use the rest of the 5 minutes to go to the application or PMP. Again, you can unmute yourself and ask questions. Okay, I'll continue. And if you have any questions, you can drop it there. So quick look at plug and play, what I can do in plug and play. So I'm on provision, device, plug and play. I can go to any of these devices which is not claimed. And I can say, claim that device. This is a serial number, and it has a template. It has all configuration. I want to do it from scratch. I don't want to use this one. So I'll click add device. Let me say I procured this device serial number, and the product ID is 9300. So it's 9324 TS. I want to call it SLI headquarter. And this device represents a stack. Yes, I want to do stack there. Add a device. Look at that. I just ordered it. I didn't do anything. The device is not shipped yet. I can select that device and say claim. I don't know why I selected 2 devices. Let me unselect one of them and go to SLI claim. I have 1 device now. This is the serial number. This is the product ID. Which site you want it to be on? I want it on Sunset device, floor 1. Now, next, this is the image which is found for CAT 9300, and it's defined as a golden image. So it's going to pick it automatically. These are all the information I need. Next, there's no template assigned. I have the 0 template assigned by default, and claim. Now, this is going to be pushed to the device, and once the device reaches the site and plug and play works and it reaches DNA, the DNA will push this configuration to this device. A quick look at the application policy here. I wish we had more time. We could talk about DNA more and more. There are a lot of features. It's really quick here. And as expected, the performance is not the best because the DNA is shared. So this is the application policy. I'm going to create one. And look, these are the relevant default, business irrelevant. I can play with them. Here I can define the queues for each type of applications. And then here I can map it to my classification of SP, the service provider. This is the strategic policy which I want. Once I say deploy, all devices, no matter what type it is, what platform, what version it has, is going to be deployed. There are a lot of concepts and talks about DNA. I try to give you like a 10,000 feet view of DNA. It's very easy. It's very helpful, very capable. And tomorrow we'll have another session at the same time about software-defined access. We use DNA Center and ICE to create SDA. And I hope that you get the benefit of this session. And if you have any questions, I'm ready to take it now. We still have 1 minute.
Thank you.
You're welcome, Ray. Hopefully we can see you tomorrow, guys, at the same time. And if you have any questions, you can prepare. We can talk about a lot.
Yeah, I think you have to play with it a little bit. And I probably, if I saw you after playing with it, probably have a million questions for you.
I'm ready for that. You can join us tomorrow at the same time. And don't forget, you can have it from dcloud.cisco.com. You can get, I'm using today 1.3.3 instant demo. There is a newer one. You can use advanced feature, I think 2.1.1. This is a little bit old version, but it's helpful for what we wanted to do today. Thank you so much, everyone. I hope it was helpful, and we'll see you tomorrow.
Thank you.
Thanks a lot.